Okay, day 3 of the electronic sound advent calendar. Let's have a look at what we got this time. So we had days 1 and 2 where we had the batteries, LED, and then day 2 we had a breadboard and an extra button. Where's day 3? Hold on, we've got 1, 2, there's 4. There's 3. 3's only a tiny little one. Ah, but tiny might be mighty. What we've got? A capacitor. And a capacitor, I think, is tiny but mighty. Okay, so what are we doing with a capacitor? So if you're not familiar with capacitors, capacitors store energy. They also store energy when combined with something like a resistor over time. So you can charge them up and then they discharge. So they can add an energy store and a time element to a circuit. So this is a 100 microfarad capacitor, and if we look closely, hold on, I'll turn it that way up. Will you focus? That appears to not say, oh there it is, 100 microfarad, okay. Right, so 100 microfarad capacitor, it's electrolytic, ECAP, I've never really heard it say ECAP. Take care to put it the right way around. If you put these the wrong way around, they can at best break, and at worst, I've seen them turn into rockets. It's great, but don't do that accidentally. Make sure you connect the negative pole to the lower horizontal rail of contact. So that's this one, and that's got the black wire, which makes this whole row down here negative. So LED lights up when you press the button, and never connect it the wrong way around. If you do that, insulator will quickly dissolve. Fluid will heat up, and you get high pressure. It can burst and release its a caustic fluid. Oof. Particularly high when it's only connected the wrong way, not only connected the wrong way around, but directly to the battery. So shorting the wrong way across these would be bad. Okay, well let's do the wiring and then add the battery back in afterwards. So I had to take the LED off so it would fit, but that's fine. So which way up? We got it this way up. I'll put the LED back in here. Right, and so here on the capacitor, you've got your negative along there. We'll slightly splay it. So putting it into the same row as the LED here, so it's connected across the LED there to the negative there. Okay. We'll connect the battery back in here. So although we can't see a resistor in this, remember there's a resistor in the LED, so there kind of is still a capacitor resistor. And a capacitor resistor gives you a time component. So it'll shine until basically this will charge up with some energy, and when the energy's run out, it'll stop shining. So let's have a go. So we press the button and we let go. And if you notice, it's still kind of lit. So hold on, press the button, let go. And so this tiny but mighty component adds time to your designs. And therefore it's fundamental for any kind of, I don't know, timing, oscillators, I guess if you wanted something to turn on after a certain amount of time or turn off, you'd put capacitors in different places. With just a button and an LED, it's just pretty much this is what it's going to do. There we go. Anyway, hope you enjoyed that, and I'll see you with tomorrow's Advent. Bye! I had an extra idea with this. So I've just rewired it with 2 buttons since I had 2 buttons. So one just powers on the LED. The other one, however, charges up the capacitor. Now when I let go, nothing happens. But this button here, which I've kind of stuck in at a funny angle there, allows me to discharge the capacitor through the LED. So I could charge, so turn on that, doesn't charge the capacitor unless I turn on both. But to prove that the capacitor's doing the storage, I'm going to unplug the batteries completely, press this, and you see it. See, let's do that proof with making it brighter. So I plug the battery in, charge both up, let go of both. Take away the batteries, press this other button, we get a nice bright LED. That's all using energy, and you can see it's now a little bit less bright. It's all using energy stored in the capacitor. That's cool.